Assalamu alaikum. I am Shwan Ahmed. Today I am here to you before you to discuss about laws of falling bodies. Dear students, today we will discuss about laws of falling bodies. Laws of falling body. Okay, dear students, when we release from a definite height something, then it goes to the downward because due to gravity. We know that gravity is the attraction of Earth to its center. In 1589, scientist Galileo Galilei performs some experiment releasing different masses from the leaning tower of Pisa. This is the leaning tower of Pisa. This is the leaning tower. From the leaning tower, suppose scientist Galileo release different masses, and observing the motion of these masses, he put forward three laws, and this law is called laws of falling body. First law is scientist Galileo observed that falling freely from rest, all bodies of different masses touch the ground at the same time. That means all the body cover the same distance at same time. So this is the first law. Dear students, we know that the attractive force of Earth, of any object, is actually its weight. We know that F is equal to ma, force is equal to mass into acceleration, and for attractive force we can write F is equal to mg. Actually this is the weight. This is the weight is equal to W is equal to mg, or F is equal to mg. And we know that gravitational attraction force F is equal to g m by r square. Dear students, here capital M is the mass of the Earth, and here small m is the mass of the body on the Earth's surface. So this force and weight and this force actually same. So we can write F is equal to mg is equal to g m by r square. From this equation we can cancel m from both sides. Here m is equal to is the mass of falling body, That means the acceleration of a falling body does not depend on mass of the falling body. That means actually does not depend on its volume or its shape or any size that means acceleration g doesn't depend on volume, shape, size or mass. So the acceleration of all bodies will be the same. We know that traveling distance s is equal to ut when an acceleration, uniform acceleration acts on a body, its traveling distance s is equal to ut plus half a t square. For falling body, here traveling distance s is equal will be ut plus half g t square. Here dear students, from rest, due to rest u is equal to 0 because all body falling from the rest, so initial velocity is 0. Here u will s will be equal to half g t square. So here g is the constant, that means uniform acceleration, uniform acceleration. For uniform acceleration, if t is same for different body or two or more bodies, for t same time height will be same. That means for two or more bodies, the traveling distance at the same time will be the same. For here two bodies, if two bodies traveling, the traveling distance of two bodies will be same at the same time. That means traveling the two bodies will touch the ground at the same time. So this is the first law. When two bodies of different masses falling freely from same height, then they touch the ground at the same height. That means they travel equal distance and equal time. This is the first law. So this is the mathematical explanation of first law. And second law, we know the second law of falling body. Second law is falling freely from rest, the velocity of all bodies in equal time will be the equal. That means the velocity will be proportional to its required time. We know that v is equal to u plus at for linear motion. When a body falls from a different height, then its velocity v will be 0 because it falls from rest. For rest, u is equal to 0, that means initial velocity 0, gt. We can write v is equal to gt. Here g is the uniform velocity, that means its value is constant into time. So we can write v proportional to t. So the velocity of this object v will be proportional to the t. This is the second law. So the velocity of falling body will be directly proportional to its required time. Third law is if a body falling freely from rest. Dear students, here you should remember that there will be no air resistance or any resistance, that means it fall freely without any difficulties. Then the traveling distance, current distance will be directly proportional to the square of the time. We know that S is equal to ut for initial motion. We can write in linear motion, we can write ut plus half a t square. For falling body, we can write h is equal to ut, that means here initial velocity for falling from rest will be 0 into t plus half g t square. H is equal to half into with the value of g 9.8 approximately and t square, so 4.9 t square. This is the constant value, this is the constant value, so we can write A is proportional to t square. So traveling distance for falling body will be directly proportional to the square of its time. So this is the three laws of falling body. So dear students, that's all for today. Thank you very much. Have a nice day. Assalamu alaikum.